Hi, this is Miss Boyer, and I'm going to do the notes today via this video. I'm sorry I'm not there today. This video will most likely be in two parts, so this is part one, and then I'll probably have to stop it and start another video. So the first thing we're going to do today, and I want you to try this on your own if you can, so just pause this if you want to try on your own. But the first thing we're going to do today is we're going to do this review of Algebra 1. And so our learning objective today is write the equation of the tangent line using the derivative. And so the review of Algebra 1 that we're asked to do is find the equation of the line with a slope of 4 that goes through 8, negative 9. And so there's probably two equations. There's probably one equation that is the most familiar to you that you think of immediately when you're asked to write the equation of the line. And that is y equals mx plus b, where m stands for the slope. So m is our slope. And then b is our y-intercept. And that one tends to be the most popular one. But I want to talk about one more today, which is called point slope form. So that's when you have y minus y1 equals m times x minus x1. In this equation, m is the slope, and b is any point on our line. And so because example 1 says find the equation of the line with the slope that goes through 4, or with a slope of 4 that goes through 8, negative 9, because the two pieces of information we have are the slope and the point, the slope, which is right here, and the point, it just makes more sense for us to go ahead and use point slope form because we can just plug in everything immediately. And so that's what I'm going to do. So I'm going to do 4, again, is our slope, and then 8 is going to be x1, and then 9 is going to be y1. And so I'm going to do y minus negative 9, which equals 4 times x minus 8. I'm going to clean that up a little bit because subtracting a negative turns into addition. And this right here will be my answer. And so this is the equation of the line in slope form. You could also use y equals mx plus b. That's fine if you like to do more work. But for the purposes of all the problems we're about to do, writing the equation of a tangent line using the derivative, it is so much quicker to use point slope form. So I would encourage you guys to start getting comfortable with that. So if you need more time, you can go pause and go back. But this is a review of that worksheet that you're supposed to do on Wednesday and that you should have finished for homework. And so the derivative is just the slope of the tangent line at a specific point. So we've talked about that a little bit, but I just want to keep putting that in your brains. The derivative is just the slope of the tangent line at a specific point. And so on your notes, this is what you should see. It looks like it erased it a little bit when I sent it to Notability. Equals 2x. And then f prime of 2 equals 4. Okay, so that's what your notes should say. And so over here on the right, what we have graphed is the function x squared. It is just a quadratic. There is nothing too crazy. And then f prime of x is going to be the equation for the tangent, for the slope of the tangent. And so f prime of x is just the derivative of f of x. And if I would have made you guys use the definition of the derivative, you would have gotten 2x out. And then f prime of 2 is just 2 plugged into that equation above, but more specifically, it is the slope of the tangent at that point. So if I would have plugged in f prime of 2, if I would have plugged that into that equation, I would have gotten 2 times 2, which is where I get 4. And so I'm going to demonstrate how you would have gotten that all from the graph too. So again, this is the function x squared, and say I'm trying to find the slope of the tangent at 2. So that's because of f prime of 2. So I would go to 2, and I would draw a line coming from the inside of the curve, and I'm going to try to draw it as straight as I possibly can. So it's not going to be perfect, but we'll just try our best. And so I'm going to pick 2 points then. So one of my points is right here, 2, 4. And then I'm going to put my other point at like right here. So this point right here is 2, 4. And then this next point is like 2.56. And so if I wanted to find that slope of the line, I would do rise over run. The scale here, it just pay attention to the scale. So this is going up 1 over 1. So if I'm doing rise over run to find my slope, I would get 2 and then my run was just 0.5. So I'd have 2 over 0.5, which is 4. So if you see here, the slope of this tangent line right here is the exact same thing as the derivative at 2, and that should always be the case. So the derivative at 2 is the same thing as the slope of the tangent line at 2. That's going to come in a lot of handy with what we do next, and that should have been just review the last couple days. So I wrote here, we now know how to find the slope of the tangent line. You just take the derivative. But what if we had to find the equation of the tangent line? So we don't just want the slope, we want the whole equation. So we're going to keep working with that last example right there. And just in these blanks we had if f of x equals 2, we had f prime of x equaling 2x, and then we had f prime of 2 equal 4. So sorry, that just got cut off. But this question asks us, find the equation of the tangent line to x equals 2. So we want to find the equation of this line right here. And so you might be able to estimate what the equation of this line is just looking at it graphically, but I think it's really important for us to do this algebraically too, because sometimes we just can't draw a perfect tangent line. And so that would make our answer a little off. But if we want to write the equation, we're going to use this formula again. So we're still going to hang out with point slope form. Hold on. Y minus y1 equals m over x minus x1. And so m stands for the slope of the tangent line, but we also talked about the fact that the derivative is the slope of the tangent line. So I could also write here, I could write f prime of x equal f prime of x times x minus x1, just to indicate to you guys that the slope and the derivative at that point are the exact same thing. And so the two pieces of information I need says y. So the two pieces of information I need here is m, or in this specific case, f prime of 2. And then the other problem I need is the point at 2. So I need the derivative at 2, and I need the point at 2. And so we already know what the derivative at 2 is because it's up here. It is 4. So I'm going to have y minus y1 equals 4 times x minus x1. And then we just need at least 1 point on this line. And so because this graph is like a pretty easy to read graph, you can tell right here that this point is 2, 4. So I can go ahead and just plug that in. Y minus 4 equals 4 times x minus 2. And so that's our answer. But let's say that we didn't have a picture of the graph, or the graph was just like a little harder to find. If we wanted to find this point right here, 2, 4, 2, 4 is on our original function. Our original function is f of x. So what we could have also done is we could have plugged in f of 2 into this equation. The original equation was x squared. So we would have done f of 2 times 2 squared, which was 4. So we could have also gotten that point that way. So take a second and look over this. And then I'm going to pause this video and start another one because the bell here is about to ring. So I'll have to finish it later.